Okay, Assalamualaikum warahmatullahi wabarakatuh. And hello everybody. We will continue the next chapter for cellular and molecular biology course, which is on mutation. All right. So first and foremost, in this chapter, it is actually a continuity from what we have learned on the transcription, translation, and then at the end of the story, from the gene that we transcribe, we will be able to get a protein. So there is some cases that if there is a mistake in the genetic makeup or in the DNA composition of a cell, what are the impacts that will happen in the process. So that is what we are going to take a look on this chapter that is more explaining on the mistakes in the genetic material, or the other name is it is known as mutations. So by definition, mutations can be defined as alterations in the DNA molecules that making up our genes. So this mutation can occur in two ways. The first way is that it can be passed from a parent to its descendant. So this is what we call as inherited defects. While it can also occur through a mutation in the reproductive cells. So if it involves this, usually the effect is observable, okay, and they can also be inherited. But in this case, if they are affecting our reproductive cells, we call it as an inherited disease. For this, okay, that is passed from your parents called as inherited defects. So if you see here a few examples of inherited disease is like diabetes and muscular dystrophy. If let's say your father or your atuk, your grandfather has diabetes, so you have the tendency to get these genes, or have the tendency to also get this disease. We there are also some of the defects. So defect is usually not a disease, but it is affecting specific organs. For example, in this right hand side picture, you can see the cleft palate of the baby, where there are defective of their palates, okay, dekat atas langit. And also they can occur as a cleft lip, and together with the cleft palate, if the baby is having this kind of problem, he or she would have difficulties to ingest food, which will affect its growth. So these defects can be altered. Okay, it depends. Like if it is a color blindness, so it only affects your eyes, so it's not totally the whole body. So if, for example, color blindness, this one cannot be treated. While cleft palates, it can be fixed. Okay, so the susceptibility to the disease is also influenced by the genetic constitution. So usually the mutation, these kind of disease or defects are actually is a result from the alteration of your DNA. So there are actually several types of mutations, and most of them have a very minor effect, and sometimes it is not noticeable it's not noticeable. Okay, some people got mutation or mutated, but it is not, they don't show or exert any noticeable effect. Okay, so if you see in the sequence of your DNA bases, this is how the mutation occurs. So if we see that the definition of mutation, it is the change or alteration of your base sequence of your DNA. For example, the CGC, so the middle base here is being altered or changed to T, so causing the amino acid that will be translated in the process of translation will carry a different type of amino acid. So this is the example of several types of mutation. It can either if you see the first one, the first line is a wild type. So usually, if a DNA a DNA material okay, doesn't work. Okay, for example, if there is no alteration, so let's imagine that the cat sat on the mat. So if you remember the three bases, okay, jujukan untuk ketiga-tiga huruf ataupun base, okay, it is arranged in the arrangement of three bases, because each of these three bases will if it is translated, it will bring to, or it will be translated into specific amino acid. Okay, so this they gave you the example in the form of a sentence like this, so that you can see clearly how the mutation is affecting the sequence. Okay, so usually the sequence that don't have any alteration on its DNA bases are called as wild type. Okay, so so substitution is substitute. You mean you change, okay, from cat you change it to rat, or change the C to become R. So this is substitution. Insertion means you are adding an additional base, okay, like this. Set becomes pad, so that means you insert one. The insertion can be either a single base or multiple base. So this will also occur as a mutation. It can also be deleted, whether it is a single or multiple bases. Inversion, so that means cat diterbalikkan, okay, the inverted to be tag. Okay, it can also occur in a large manner where the whole thing are reversed or is inverted. So because of this, you will be getting the whole sequence to be something that is totally different, giving a different meaning, giving a different translation. Okay, it will translate you to a total these are dangerous because it affects, or it is affecting the whole sequence lah. Okay, so so what are the effects when there is the alteration of the DNA sequence? So the bad thing is about the alteration of DNA sequence is that your original DNA that is the new mutated sequence will be inherited to your next generation. Okay. So as I said before, if you have alteration of your RNA or DNA sequence, it will be translated into altered proteins. So this will cause further reaction from small, whether it is small changes or small impact to your body, or it can even give a huge impact that involve a vital reaction that your body has to receive towards those reaction. Okay, so let's go one by one towards to the types of mutation. So silent mutation is the types of mutation that doesn't give any effect to the operation of the cells. So why does we say this is, if you see in the DNA sequence as an example here. Okay, so this is your DNA strand, and that the mutation occurs somewhere um, in the DNA sequence that is not important. So the bases um, that involve alteration is not at your desired genes. So because of this, your DNA will produce or transcribe and translate protein as usual. So this is why that we say that sometimes there is no significant impact. Badan kita sendiri pun possibly have undergo some mutation, but because they didn't affect um, our desired genes, the important genes, so it doesn't really exerting any impact to us. Okay. So usually the changes occurs in the introns. So you remember, if you translate your DNA, you'll be getting mRNA. So before this mRNA being translated into proteins, they need to be repackaged, where they need to remove all the introns and take up all the exons. So exons means the DNA sequence that is functional. Okay, introns means doesn't have any function. So they need to remove out all the introns and combine all the exons so that they can be a functional or pre-mRNA to be mRNA before it is being translated into proteins. This is another example that the mutation occurs in the non-coding region. Okay, like I said just now, all the exons are combined, and then you can translate as usual without any protein changes. Silent mutation also can occur in the coding region. So that means yang tadi tu dia berlaku di kawasan yang tak ada impact. It means it happen in the introns sites. So but sometimes it can occur in the region that is important, okay, like in our genes. All right, so in this situation, how bad it can impact the cells. So it actually depends on the types of alteration that occur. So we have to take care of the codon table here. So you have to look back on the codon table and always remember that there are 4 possibilities. Okay, for we have 64 different codons, and we have 20 possibilities of amino acids for one codon. Okay, so for example, those who of the amino acid to translate in phenylalanine, it can be either UUU or UUC. So if there is an alteration among these two bases, as long as it denotes or it's giving the same or alteration that still translating into phenylalanine, then it doesn't give a bad impact. Okay, so for instance, in alanine will encode for 4 codons: GCU, GCC, GCA, and GCG. So if any codon in the form of GCX. So X can be at any base. So as long as the mutation occur at the end of this sequence, so it doesn't matter because they are still giving you alanine. Okay. Now we go to missense mutation. So missense mutation is a little bit different because it can cause a moderately bad mutation. Okay, in silent mutation, it is a silent type, so it's not really bad. Okay, so missense mutation, this is where you can see that this sequence GCA is changed to GGA. Unfortunately, if you check in the codon table, so GCA, GGA is actually translated into a different type of amino acid where they also have different characteristic. You have to also check. The first thing is that what type of amino acid it encodes to. Okay, now that we know that ALA has become glycerine. So after you check that both of them are actually not the same type of amino acid, you have to look back on the characteristic, and then when we check on the table, okay, glycine and alanine. So although they are a little different in terms of the type of amino acid, they are still these amino acid are still regarded as a non-polar type of amino acid. So they are still in the same group. Okay, so it shouldn't be that bad because they are small type of amino acid and they are uncharged. If they are not non-polar means they don't have any charge. So they are having same characteristic and they still can work like normal, like alanine. So replacing alanine and glycine in a protein will probably not radically alter its structure. So the critical regions, the critical cases is that if they become little, the changes of one amino acids to another can give a different characteristic of the amino acid. Okay. Okay, if you look here, GCA is alanine, and the changes of C to be A will cause it to become mana tadi? Dia jadi GLU, glutamic acid. So tadi tu alanine. Alanine is a non-polar, and right now it's becoming glutamic acid. So you have to look back on its characteristic of each of the amino acid. So now glutamic acid is a charged type of amino acid, and this is a non-polar type. So what happened if, let's say, we look into a broader side that alanine that is non-polar, okay, non-polar, become negatively charged. And if you see the way it folds, also giving into a different morphology or different kind of folding. So it's still folding, but maybe the amino acid is located here could form an interaction with glutamine. Because of that, it looks like closer to each other from this strand to another strand. So from here, you can see that the folding pattern has been changed. So there are possibilities of this amino acid also giving a different effect. Okay. So this is still considered as a bad, but it's not that bad. So is a pretty bad mutation. Okay. You have to really look at the characteristic when it change and what will happen. Okay, on the protein afterwards. Okay, when it is changed, whether it can be that bad that cause the disintegration of the protein. That is the final thing that we want to look at. Okay. For some of the example of missense mutation is a protein, okay, that is folds properly at low temperature, but at high temperature, what happens is that the protein is not stable and unfold. So this would reflect to this situation, okay. So at normal temperature, maybe this nothing happened, but when it is the protein, because protein is very sensitive towards temperature. Okay, if you work with protein in the lab, if let's say in your final year project you are working with protein, you have to be very careful when you're dealing with protein, because you need to always keep your protein on ice, because if you left your protein just on the bench on the countertop, okay, your protein will be rosak, they will be disintegrated. So you can't use your sample anymore. You have to redo it again to gain back your protein. Okay, I don't know lah what kind of protein, because some of the researcher, they have like specific protein they are working on to study on something. If they do some modification, would that give any benefits ataupun I don't know what they're working with, but basically when you work with protein, that's what you have to take care of. So this situation in this slide, we can relate with the explanation here, because there are sensitive mutation towards temperature. Okay, that involve a protein. So protein, kita tahu protein tu dia boleh fold, dia boleh untuk dia function. For a protein to function well, they need to be folded. If the protein is not able to be folded, so they cannot function well. So a protein that folds properly at lower temperature, but at high temperature, because kita tahu macam ada setengah negara tu dia ada waktu sama, waktu sejuk kan, waktu sejuk dia boleh fold. Tapi bila dekat high temperature during summer, the protein is not stable and then they cannot fold. The example is the mutant is the example is this cat. Cat is a warm-blooded animal. So when during cold season, during when it snows, so there are some color changes in its paws and its nose. Okay, so that means the enzyme in this area is active. However, at high temperature during summer, for instance, so dia tak ada lagi patches on the side of the body. Okay, these are the example of indicator, okay, of a mutant. The third example is a nonsense mutation. So when they say nonsense, means something that is really, really bad, because when there is a mutation of one basis that leads to a stop codon, so that means that this basis is not properly being translated, that it has to stop. So because of this, the ribosome that are making the protein during its translation process, they has to stop. So the rest of the protein is not able to be made. So this is the UGA stop codon. One of the diagram that show that that the process of translation cannot be finished, and what happened is that when it stops before it finishes, this protein will not be functional, and it has to destroy this protein from being used. These are also called as a chain termination mutation, where the nonsense mutation are often lethal. Okay, so that is the really bad type of mutation, because it's totally disrupted the whole protein. The fourth type is the deletions and insertions. So in this case, the DNA alteration involve the missing or the removal or the addition of one basis or more. Okay. So if let's say you see here the wild type means the original DNA sequence, and then the mutants is that there is a deletions of certain or specific bases in this GUA codon. What happened is that when you want to translate this, okay, it's supposed to get a valine amino acid, so they have to injectkan. They have, when they delete this, so this could it is shifted to be a GAA. So it totally gives you a protein that is totally different from the original translation. So with just a single base deletion, the protein sequence are completely disrupted. This is also a real bad situation or a real bad mutation. If they insert a single extra, okay, there are two things that might happen here. The addition of single base and also addition or deletion of two bases would give changes in the reading frame. So these are also known as a frame shift mutation. Okay. However, if the insertion or the deletion occurs in three bases, this is something that could give a totally different effect, because the deletion of three bases, it will delete a specific proteins here. However, the other types of amino acid that encodes this sequence will still be produced. It's just that it's missing one type of amino acid. So so it actually remains the type of other proteins that is formed during translation. So as long as the deletions did not occur on the active site, the mutation should be fine. So in the frame deletion mutations, you have to really look. Okay, the first one is that you identify which mutation is happening, whether it is a deletion, insertion, okay, or apa insertion, deletion ataupun the revert. Okay, so you kena tengok the macam mana, how the mutation occurs. The second is that when you translate it, do you still get the same amino acid like the original sequence? And after that, there are 3 steps. After that, third step is you look on the structure like this, the protein structure, how bad it will impact to the protein well-being, whether it can be folded or not being folded, and also whether it is affecting your active site or not, because the active site is very important, because this is like the heart of protein to function, because without the active site they won't let the protein to function well. Okay, so so as a conclusion, it might be okay to delete or add more than 3 bases as long as it is a number in the multiple of 3. However, if you delete 1 or 2 bases, it might cause problems on the functionality of the protein. In the deletion and insertion, it can occur whether it is a small type of deletion or the large deletion. So if let's say this is a original DNA, they have like 2 genes, and the mutant DNA, you only get these genes, and these following genes are not being able or not are not here. So this is what we call as a large deleted mutation. It involves the whole genes. Okay. The I think this is the last type of mutation, the inversion and translocation. Inversion is like a terbalik kan, the inverted segment. For example, gene 1 and gene 2 is being inverted to be 1 on this side and gene 2 on this side. It becomes backwards. So the definition of translocation is a little different because it involves the whole gene here, and it will insert the gene in other location in the other location that is important. So that is why they call it as a translocation. Trans means you transfer or you pindahkan, and then you locate it somewhere else. Okay, so what happened is that this gene is totally being disrupted. Okay, because part of the gene 2 here is being inserted here. So this is getting real bad. So how does our body, or how does the mutation occurs? There are several it has been identified that there are several ways of a person or cells can be mutated, and mostly it is because of the agents. The use of agents uh, like chemicals mutations, like toxic chemicals, and also can be a physical mutation that causing a radiation. This is what we call it as an induced mutation. It is induced by an agent. So it is caused by something. Spontaneous mutation, there are no dangerous chemical radiation, but it is more or less because of the errors in our DNA replication. So because the process of replicating of our DNA, it occurs very fast, they have a tendency to make some mistakes. Okay, these are some examples of mutagens. For example, the EMS, ethyl methane sulfonate, nitrite, and if you ever heard of bromouracil, for instance, so this bromouracil, they have the tendency to mimic one of our bases. We have 4 bases, right? So bromouracil, they have tendency to resemble thymine. So you most probably would be having arrangement of your DNA that was forming a hydrogen bonding in using a different type of bases, which is thymine. Okay. Another thing is this one is acridine orange. So it is very important because nowadays you are still not able to enter the lab, and if let's say you have apa ada orang panggil ada peluang untuk buat lab, when you are working with any chemicals, it has to be very important to first check the name of the chemicals and look at the MSDS. MSDS is a safety data sheet, SDS. So this SDS is usually can be easily found through Google. Okay, because people are sharing the this data sheet. So before you enter the lab, you should be responsible to read on the safety data sheet, because we never know the chemical that we are dealing with is a toxic agent, and because in the safety data sheet it will explain to you if you are like having a high exposure of that chemicals, what will happen to you, how to remove those agents from your body, how to how um, to help you to get away, ataupun macam kalau you dah terkena toxic ataupun macam tu, macam you nak bersihkan you punya diri daripada bahan-bahan yang berbahaya. So it is very important. Okay, like for instance, this is a acridine orange. So acridine orange is usually used for staining when you're working with cells. For example, if you work with cancer cells, for instance, you wanted to know the differences of normal cells and cancer cells. And we know that cancer cells, they are growing rapidly. So, any chance that you could see the differences is through staining. So people use this kind of staining. It is very effective that it is enable you to see the differences of the cell stages. However, it is very dangerous. So because if you are exposed to acridine orange, it will mimic the base pair sama macam bromouracil tadi. So it causes intercalation of your DNA. So it acts as a intercalating agent. So they gave you like a it is like a new other bases. If, for example, this is supposed to be T and A, and then it can be mixed with one of the bases and then forming like a different types of bases here. So at the end of the story, you'll be when this DNA is duplicated or replicated, it will give you a totally a different basis. This is what happened. This is the mutation occurs somewhere here. This is what I explained just now. So you can basically see your cells in the green color, and then the acridine orange will differentiate you with the normals, or you can see the differences of the cells, the normal cells and the abnormal cells. Okay, and then it can help you to see the cell cycle. If you look on the definition of acridine orange, this is the definition. So you do the staining for in your fluorescence microscopy. You have to, this is a different from light microscopy because you have to use a fluorescence lights to observe your cells. So other agent is a teratogen. So the example of teratogens is thalidomide. Thalidomide is very popular long time ago, and if I'm not mistaken, thalidomide is given in a kind of supplement for human. I can't remember, tapi yang ni those pregnant ladies yang take thalidomide, they resulted the birth of malformed children. So untuk orang yang pregnant, dia consume thalidomide. Bila dia beranak, dia menghasilkan anak yang mutated. So thalidomide is believed to have a mutating agent. Okay. Physical mutagens are examples of radiation like UV light. Okay, please be very careful with UV light. There are some incidents that was reported that students are exposed to UV light. They don't really take care on the SOPs on the MSDS sheet. They thought that there is nothing will happen to them, but actually in the long run, if you have like a high exposure towards this radiation, it will giving you this observable effect. Okay, might not happen to you, but may happen to your generations because you are carrying a DNA sequence that is malformed or disrupted. Okay, this is a UV light. The effect of UV light, it will cause thymine dimers. So dia akan boleh menyebabkan macam bridging dekat sini, two neighboring thymine. relocation. Neighboring timing means timing that is sitting next to each other. So if you are induced with UV light, they will cause you a dimer. So they will form TNT, they form like a bridge here ataupun double bond here, and then forming a barging disc here. So what happened is that when this DNA will be used for further replication, it will cause problems in synthesizing new DNA sequence. The other thing is UV radiation. So, and X-rays. Not only that, some other radiation like alpha and beta particles, gamma rays, those are the things that you need to really be careful of that. So remember that we have mutation that is caused by agent, which is a chemical or in through the physical exposure, like the chemicals and also the radiation. We also have a spontaneous radiation. So spontaneous radiation is spontaneous mutation. Sorry, spontaneous mutation is a mutation types that occurs in our body because of the DNA replication. And if you remember this transposon, so this transposon apa tu? Transposon, if you remember, it is an insertion sequence. It is a small base of your DNA sequence. Okay, kalau you ingat dia ada kat hujung sini, dia ada inverted repeats. Okay, so this transposon, it is very unique because they are able to jump from one to each other. So because of this characteristic of transposon, when they are relocating, they're able to insert themselves in the middle of another gene. Because of this, they will disrupt the target gene and could impact the proper function of the genetic material. So these are the example of mutation of the transposon. We know that transposon, they can jump from one to another. So if they are mistakenly jump in between this gene, so what happened is that the gene is totally disrupted by the transposon. So these are what we call as a spontaneous mutation. Okay. However, this genetically engineered gene disruption. So this kind of gene disruption is not all the time a bad thing. Okay. So this genetically engineered gene disruption sometimes can be very helpful because so we can design the segment of the DNA because they use this gene to do some modification. Okay, so if you read all through here, this disruption, they can clone the gene and then they can, play around with the gene. They insert something in between and they analyze what will happen. So one of the successful invention is that the development of gene cassette. So gene cassette ni adalah satu gene that carries a gene for resistance to some antibiotics such as chloramphenicol and kanamycin. If you remember, resistant gene, and also if you remember the restrictions enzyme, you can cut up the resistant genes. Okay, and then having like a sticky ends. So if you potong or cut these genes and then insert it in other plasmids, for instance, using the restriction enzyme. These are called as a gene cassette. It's like a technology that help you to do more modifications for experimental purposes. Okay, so insert DNA can be easily detected because cells that carrying it will carry some resistance to the antibiotics. So because of this, it is considered as a good thing. At the end, at each end, the cassette has several convenient restriction enzyme sites. Okay, you can read this all through, but the most important is that it is wanted to say that it's a antibiotic resistant genes that could be helpful in the experimental purposes. Okay, I think this is the last subchapter. This is about reversion and suppression. So what is a reversion? So suppose that we have a mutant. So now we know that our DNA, okay, kita dah tahu that our wild type DNA, this is our sequence. And then if let's say we are exposed to some agents or there are some spontaneous mutations occur in our DNA sequence, so there are some deletion, for instance. So what will happen is that the protein produced by our body has a totally different from the original protein that is supposed to be translated. So this is the revertant is okay. The revertant is actually referring to a, a, a characteristic that help or enable us to mutate again the mutated sequence. Okay, we know that it is already mutated, but we can revert it back to normal. So because of that, we call it as a true revertance. So we try to revert back and find where are mistakes, where are the mistakes in the sequence, and we try to revert back so that we are getting the original sequence that imposed by us. Okay, so in the end we are getting the same sequence of the protein like the first one that we had. Okay, so this revertant is actually helping us, okay, to restore back our DNA sequence. Okay, and these are the examples. So these are misfolded protein. Okay, misfolded. I cannot see misfolded mutant protein. So imagine that this is our original protein. We have okay, the shape is like this. And when there are mutations, Yusof, jangan panjat Yusof. Okay, the first mutation, what happened is this. Okay, you just look at the red box here. Okay, so this mutation cause the changes of amino acid at its different characteristic from positive to negative to positive and positive. So it changes one of, I think it changes here. Okay, so this side has been changed to a charged type of amino acid. So if you see this, when it is positive and positive, it repels back. So it doesn't, it's not like a magnet, dia tak boleh tarik kan. So what happened that you can see that this protein, they cannot fold as good as the first one. Okay, dia tak boleh nak fold because positive and positive dia repel, so dia macam dia punya structure tu not compact. Okay, we can see roughly from here to just to give you understanding on the so a true revertant could be made by replacing AAA with GAA. So that means they're trying to revert back so that they can get this positive and negative back. Okay, so they use a true revertant. So so they do some mutation again on this side. So these are called as a second site mutation so that they can restore back the original site here. Okay. Another thing is on the DNA repair. So if you read in this sentence, most cells contain a variety of damage control systems, and some of this can repair damaged DNA. A variety of mutations may result in a base pair that doesn't pair properly, and this will result in a slight bulge in the DNA double helix. It's like the thymine dimer just now. So this repair system, what happens is that they can cut out the wrong base and fills in the gap with the right base to make it a correctly bond repair. So this is something like yang tadi tu dia revertant. This is another way of repairing your DNA. So this repairing, they will identify which one is having a bulky DNA sequence, and they will try to do some mismatch repair system by replacing a specific basis here. But which of these two mispaired bases was the wrong one? How to know whether it is a wrong one? We need to know which strand came from mother cells and which was the recently synthesized. So they need to find out which one is the original strand so that they can do the repairing of the DNA. All right. So yang tadi tu, we call it as a excision repair. They cut and they patch the repair. Okay, for example, a thymine dimer. Okay, remember your thymine dimer? This is a T and T. Okay, T and T is not supposed to have a double bond with themselves. Because of that, they form a bulging. So they need to repair the bulging. So these are the bulging on this side and the other side, on the daughter and original DNA. They need to cut them and patch them back so that this can be repaired. Okay. So, by these processes, I'm sure that you are wondering how this DNA repair, this is a mechanism, how our body can do some repairing. This is more on the gene therapy. You will learn more on the gene therapy because it involves involving the repairing of the DNA sequence, like in these cases. So if you look on the conclusion, okay, so mutation are generally of vital importance to us for two main reasons. First, if a mutation occurs in the reproductive cells and it can be inherited, it may have a major effects on the lives of those who receive it. So these are referring to our next generation. Secondly, mutations that are not inherited but arise after birth in cells or body may cause cancer. So we don't inherit, but we are exposed to UV light, the X-ray or beta or gamma rays. We are exposed to agents like bromouracil, tadi acridine orange. We don't inherit them, but they can cause us cancer. So it's causing some disabilities to our body. So it's the end of chapter 4. Chapter 7. So so your final will be until from chapter 1 to chapter 7. Chapter 8, I will pass to you on the recording session later on. So I make this lecture to be very simple. Okay, it used to have a very long explanation beforehand. So I've cut most of it and try to focus the most important points for the subchapter. So it's nothing much differences with those that you have learned before. So it's just like a recap for you. Maybe you got some additional information. Just kukuhkan lagi kita punya pemahaman dalam subjek ini. Right, so I guess that's all. So we will We will continue with our test too on next week. So I hope everyone please be prepared. Try to read from the translation, a bit on transcription, or more on translation, and the way afterwards. Okay, the chapter upwards until the mutation. Okay, so all the best for everyone. Thank you for listening, and bye bye. Assalamualaikum warahmatullahi wabarakatuh.